Okay, so now let's discuss data types. Now, can you quickly tell me how many data types we have in Java? Just data types. What are those two data types? Okay, so that's true, but I'm just talking about predefined data types. So we have 8 data types. Okay, we have 8 data types in Java. We have byte, we have boolean, okay, we have byte, we have boolean, we have sort, we have char, we have int, we have long, we have float, we have double. Okay, so the primitive data types means the predefined data types. So we have altogether these 8 data types. Okay, and in Java we should not say primitive data types and user defined data types, because we never create our own data types. We just create our classes, and the classes are not data types. Correct? So I believe in Java we should not say we can have user defined data types, because generally do we create any other bytes or boolean? No, we just create a classes. Okay, so in Java we have 8 data types, and these are the 8 data types. So the size of this byte is 1 byte, the size of the boolean is 1 byte, sort you have 2 bytes, character you have 2 bytes, integer you have 4 bytes, float you have 4 bytes, long you have 8 bytes, double you have 8 bytes. Okay, so I just arranged that with respect to the size 1, 2, 4 and 8. Okay, now because the Sun microsystem has given 2 bytes uh, for these characters. Okay, now integer they have defined 4 bytes just because to hold more and more values. Just to hold more and more values. If you talk about C programming, then the integer size generally is 2 bytes, but again it depends from a processor to processor. Yes, so I'll talk about that when we discuss character. Okay, so if you talk about the straightforward data types, there are 8, and if you want to categorize it, then the data types are of, I'll say 3 types. Okay, I'll say 3 types. One is numeric, another one is character type, another one is boolean type. Okay, in character type you just have character, in boolean type you have just boolean, but in numeric you have subtypes. One is integral type, another one is floating point type. Okay, in the integral type you have byte, sort, int, long. In the floating type you just have float and double. Okay, now let's do some mathematics. I'll start with byte. What is the size of the byte? 1 byte. Okay, is equal to how many bits? 8 bits. Okay, now can you tell me what would be the range? The range of this byte would be 2 minus 2 to the power, okay, minus 2 to the power 8 to 2 to the power 8 minus 1. Okay, the range of this byte is minus 2 to the power 8 2 plus 2 to the power 8 minus 1. Yeah, we will talk about this. What do you mean by the range? So first of all, what would be the value of this 2 to the power 8? 2 into 2 4 into 2 6, sorry, 2 into 2 4 into 2 8 into 2 16, okay, into 2 32 into 2 64, sorry, 8 bytes. This will not be 8, it would be 7. It would be 7. Yeah, okay, when I say 8 bits, so the range will go minus 2 to the power 7 to 2 to the power 7 minus 1. So it will come across, the 2 to the power 7 value will be 128. Okay, 128. So minus 128 to plus 127. Okay, because here minus 1 is there. Alright, now what do you mean by this range? Now range means what is the value it can hold. For example, let's say I defined a byte. byte b equal to 10. So this 10 is within the range or not? Okay, so you will not have any problem. But if you try to store byte b equal to 200, byte b equal to 200, so this 200 is not within the range, right? It is out of range. Now you cannot store this value. Let's see what it says. New, or I'll copy paste this. Okay, so I'll say byte b1 is equal to 10. Okay, and again I'll say byte b2 is equal to 200, and I'll try to print b1. I'll try to print b2. Let's say Java C star.java. Okay, see here you got some problem. What it is saying? Possible logic conversion from integer to byte. When you define this 200, this 200 is out of the range. Okay, this 200 is out of the range, and it is thinking that this 200 is an integer, and you're trying to assign it to a byte, which is not possible because the byte cannot hold that value. Okay, so whenever you are trying to store any value to any data type, make sure that it comes within the range. For example, let's say I want to store all the students' roll number. Okay, I want to hold the roll number of any student of a class, and I'm sure that there will not be more than 100 students in any class. Okay, you might have studied, you might have observed that when you were in your school days. Okay, we used to have different section, let's say 10A, 10B, 10C, right? But everybody learns the same thing, the syllabus is same. The only difference was because of too many people, too many crowd. Okay, there were not enough space, so they started dividing the sections. Now let's say in any section there will not be more than 100 students, so every time you can always say byte roll number equal to 100. Getting my point? So you can hold the student roll number, okay, using byte, because our school has a restriction that no class will have student more than 100, and this is good. Like byte will be able to hold that value successfully. Tomorrow when it got increased to 150, you will be in problem, right? When the total strength of any class got increased to 150, you'll get into problem, and then this byte you cannot use. Okay, now let me go to some memory diagram. Okay, here 1 2 3 4 5 6 7 8. Okay, so let's say this is one bit. Okay, sorry, this is one byte. Okay, it has 8 bits and each bit can store 0 and 1. Okay, so I'll say 7 6. Okay, so let's say this is all bits. Okay, and here you can either store 0 1 in these places, and I'm just talking about byte. Alright, now how many boxes you have here? 8 boxes. Out of these 8 boxes, this box is called LSB, least significant bit, and this is called MSB, most significant bit. Okay, and this one is a sign bit. This one does not store any value. Okay, this does not store any value. This just store the sign information, whether the number is negative or whether the number is positive. Because you can always say byte b equal to 10, byte b equal to -10. Right, so there should be something to differentiate this, whether it is a positive number or whether it is a negative number. So this bit, the last box, is basically just to store what? The sign. It stores 0 and 1, but this is not for data. Here on the sign bit, on the sign bit, 0 represents positive, 1 represents negative. Okay, now one box is gone. Now how many boxes we have? 7 boxes. Is not it? We just have 7 boxes. That is the reason the range is 2 to the power 7 to 2 to the power 7 minus 1. Okay, now when you try to find out this one, that goes to -128 to 127. Are we clear? If the number is 150, you cannot store that in byte. You have to choose any other thing. Okay, so what this will give? This will give you error, possible loss of precision. Found int, expected is or required is byte, right? See, roll number equal to 150. So 150 is not capable, like 150 is bigger enough to be stored under byte. So you'll get possible loss of precision. Found integer but required is byte. When do we use byte? When you have range within -128 to 127. Okay, and while performing file operation and you are reading the data from file, we use byte, or more specifically we use something like byte array to read the content from file. Okay, so this is out of the context now, but in the real time whenever you are trying to read the data from file, you may be using something like byte array or byte to hold the value, to hold the data from to hold the data which is read from the file. Anybody has done this? Okay, similarly, now what I'll do is, let's do one thing. This byte plus 127, this is the highest value it can hold, is not it? -128 to plus 127. Compiled successfully. Java Datatype test. Datatype test. Why am I getting 3 output here? B1 and B2. Okay. To read the data character by character. Okay, so Java data type, you see 10 and 27 we got. Yeah, you can do that. Okay, now I'll change it to 128. What do you say? Will it compile or not? I changed byte B2 equal to 128. Right? It should not compile. That's fine. So I'll say 127. Okay. After that, I'll say B2 plus equal to 5 or plus equal to 1, let's say, or for the timing, let me just say b2++. What will happen now? Same thing, same error. Naresh says there will not be any error. Okay, so if you feel that there will not be any error, then what will be the value when you try to print it? Okay, but if you feel b equal to 128, byte cannot hold 128. What will be the value? That is the interesting point. Okay, first thing, let's see whether it is compiled or not. Okay, it got compiled. Okay, now I'll say Java space data type test. Okay, hit enter. The output is minus 128. Yes, we'll see that. We'll see that how the output is like that. Okay, now what I'll do, I'll say 5. Okay, what will be the output now? Compiled. What will be the output now? Okay, minus 123. Okay, the reason is all these data types, they maintain a cycle. So let's say you have here, what the maximum value? 127. Then 126. Then 125. Okay, here 0, and after 0 it would be minus 1, minus 2, minus 128, minus 127, minus 126, minus 125, minus 124, minus 123. Okay, they maintain a cycle like this. So if you see 0, here you will be having 1, then you will be having 2, then you'll be having 3. Okay, so 0 1 2 3, and it will come 125 126 127, and here there is a reverse cycle, 128 127 126, it goes till -2 -1 0. Now what we did is, our value, the byte was holding 127. Okay, so this byte was holding 127, is not it? Then what I did, I said plus plus. When the byte is 125, when the byte is 125, value is 125, and when you do plus plus, it will jump to the next value. Is not it? It will jump to the next value. Again, from here again, when you say plus plus, it will jump to the next value. Similarly, currently my byte value is how much? 127. Okay, 127. And when you say plus plus, what will happen? It will jump to the next value. Okay, that's the reason it was giving you -128. And then what I did, I said plus 5. Okay, currently it is pointing to this location 128. Plus 5 means 5 times it will jump. 1 2 3 4 5. So the value is 123. Got my point? Similarly, now what I'll do, my current value is 128, or sorry, 127. Okay, and from here to here, how many values you have more? All 128 values. Okay, so I'll say plus equal to 128. Okay, let's compile this program. Okay, I have to make it 127 to 128. It is jumping. We are here. It has to jump 128 times. When it jumps, it comes here. When it jumps only one time, it comes here. 2 times it comes here. Okay, so maybe it comes here. Okay, now when you try to jump more, program, when you jump more, then ultimately you'll get back to 0. Right, now again, when you jump more, you'll get positive values. Are you getting my point? Okay, now let's move to sort. What is the size of this sort? What is the size of this sort? Boolean is used to hold just the true and false value. We'll talk about this later. We'll take up sort. What is the size of this sort? Two bytes. So how many bits? 16 bits. Out of the 16 bits, 1 bit would be okay. Can you please type you will get the error when you directly try to assign it with a big value. You will get that precision error when you directly try to assign a big value, but you assign it small value and then you try to plus plus, you try to increment it. No worries, it will follow the cycle. Okay, even like byte, if you try to add two numbers, then also you will get that problem. I'll show you that also later. Okay, so 2 bytes equal to 16 bits. So out of this 16 bit, 1 bit would be reserved for what? Sign. Okay, how many bits left? 15. Now the formula would be minus 2 to the power 15, 2 plus 2 to the power 15 minus 1. Okay, what will be the value? You'll get the value minus 32768, 2 plus 32768. Right? That means this sort can hold the value between this range. Okay, so you can easily write sort sh or s equal to 30,000. Let's say there is a company, where after working for 10 years also the employee salary is not in will not be more than 30,000. So you can easily use this sort to hold that value. Right? Or if you want to hold some value where you know that the range, the value of that variable will not cross more than 30,000. So you can use sort. Again, in this sort also you have that cycle concept. This cycle concept is applicable for all the integer data types. Okay, now let's do something on that sort as well. I'll just comment this too and say sort sh1 is equal to 30,000. Again, sort sh2 is equal to 32768. Will it be able to hold this value? Range is sort ss3 is equal to okay. What will be the output here? Fine, let's see. Did I miss anything? Line number 19. Oh, I just copy pasted. Okay, fine. So we got that error here, right? Because of this SS2. This is out of range. That's the reason we got this error. Okay, now the first output is 30,000, the second output is 32767. I believe there should not be any questions. Krishna wants to say something. Okay, now similarly we have integer, I mean int. Okay, what is the size of int? This output? Are you talking about this output, Krishna? No, we have just incremented by 2 na. We have not incremented by 5. So incremented by 2 means 2 cycle, like 2 jump. So 32768, after that what will come? Minus 32768 will come. And then minus 32767 will come. This is what we are getting. Okay, so what is the size of the integer? The size of the integer is 4 byte. That goes to how many bits? Okay, 32 bits, and hence the range would be minus 2 to the power 31 2 plus 2 to the power 31 minus 1. Okay, and this value is really long. Okay, we have to calculate, or what I'll do is I'll just Google it out and I'll try to find out directly instead of calculating. Yeah, that is something like that. Fine, so the formula will remain same. right? See here, they are also calculating using the same formula, minus 2 to the power 31 to positive 2 to the power 31 minus 1. Okay, now no worries, I'll challenge Krishna on one thing, okay, in the coming 5 to 10 minutes. Now here, this is the range of your int, okay, and you can hold these many values. So if I talk about this, then it is so around 20 crores. Okay, so this may be sufficient to store uh, bank account details of economic people. Is not it? And here also the same thing, the same cycle concept also holds good. Now let's go to long. The size of long is 8 bytes, right? 8 byte means how many bits? 64 bits. Okay, 64 bits. Now the range will again go the same, 2 to the power 63 to 2 to the power 63 minus 1. Okay, now so 2 to the power 63 will come something like that. Okay, we'll use Google. Okay, even they have not given, they said you calculate on your own. So I'll just take up with this number. Okay, fine. So we'll just take up this number. uh, has it come all together? This is my program. Okay, now let me do one thing, just system.out.println. Okay, I'll just go here. Okay, so this is the maximum value. Yeah, I was just confirming. Okay, so paste. Fine, so the maximum value goes this one. That means the minimum value will go this. Now you can store the bank account balance of few richest people. Okay, I'm not sure how are you going to read this, but it is very long value still. Okay, in Java, if you are not happy, if you have a requirement where you are expected to hold larger value than this, okay, larger value than this, then you can use big integer big decimal class. Okay, what I mean to say is, although this long variable is capable of holding huge amount of data, okay, like huge number, but still if you feel that your requirement is beyond these values, then you can just work with the class called big integer and big decimal. You want to see the code is very simple. You just say long.maxval, it will give you the maximum value. So here also we have the concept of cycle, the same cycle what we discussed with byte. Okay, now let's move to float. Okay, now what is the size of the float? Float is 4 bytes, whereas your double is 8. Okay, now what is the range of this float? Okay, so here you are in trap, Krishna. Okay, so let me tell you, the size of this float is, okay, the size of this float is minus 3.4 e to the power 38, I believe 38 to 3 to the 3.4 e to the power 38. Let me just confirm you this. Float, okay. They have not given any data values, any sizes. No worries, if they have not given, what we will do is we'll just replace it with float. Okay, so that I can show you what is the exact value. Java compile. Okay, so that's correct, 3.4, and these are a big decimal, you can ignore this, E38. It depends, generally people should not ask you. Okay, because working people, like if the people is only working in company, then they will definitely not have time to do all this R&D and all. Okay, but if people are working as well as teaching, then definitely they would be knowing some more bit extra. So the size is 3.4. okay, and I have just ignored these decimal values. e to the power 38. Right? Similarly, the size of the size of double. Let's see what is the size of double. Compile, execute. Okay, 1.7. Okay, 1.7 𝐬308. So check it out. If you divide this by 2, what is the output of this? (1.7). No, the looping concept does not hold good here. I believe that does not hold good. We'll see. We'll try. We'll see. Try and see. Okay. E to the power 308 to 1.7 e to the power 308. Yeah, I am coming to that question. Okay. Now the range of float and the range of double is this one. Okay, now if you see, this range has nothing to do with the bytes. Okay, if I talk about integers like integer, long, or byte or short, then there used to be a fixed formula based on the byte, right? Based on the byte, these are the range, and based on the range, these are the values. But in case of float and double, okay, this floating point stores the data in some other format. I'll give you the clarity. Now, as I said, the range is this. So what would be the value of this, right? Like, this does not make any sense to me. I'm not able to understand what is the extent, till what extent it can store the value. Correct? So what we will do is, here I'll just say, let's say int I is equal to 4 e2. Let me see if this works, otherwise I'll change it to float. 4 e2 println I. Let me see if this is compilable. Yeah, so I have to make it double. I'll make it double, no problem. The last value is 400. Okay, see, this means 400. Okay, I'll make it 3. Okay, this means 4000. Okay, I make it 4. This has become 40,000. Okay, so can I say this e means 10 to the power? Can I say this e means 10 to the power? When I wrote e2, it gave me 400. When I wrote 3, it gave me 4000. When I said 4, it gave me 40,000. So can I say the meaning of this line is 4 into 10 to the power 4? other folks? Okay, now what is the range of this? You just have to assume. Okay, I cannot write it even. 10 to the power 38 means this is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, this has become 20, another 20 became 40, minus 2 38. Okay, into 3.4, into 3.4, that means I can add 34 and I can delete 10. Correct? So the range is like this. Getting my point, all of you? And if you see, the long value is nowhere, right? The long value is nowhere. Now, similarly, can you assume the range of this double? E308, that means 10, how many times? 308 times. So you have to, like, this was all 40, right? This was 38. This was 38. Okay, so this was around 38. And now I'll delete 8 from this, will become 30. Here 30 zeros are there, somewhat around. Okay, if 1 and 2 are missing, we'll ignore it. So here 30 zeros are there. You have to do it for 10 times. This is 1 2 3 4 5 6 7 8 9 10. This has become 300. Okay, now 8 zeros, right? So into 1.7, so you can say 7 and you delete 10. This is the highest value which you can store in a double variable. 2 correct. Now you see the float is nowhere. Got my point? And finally we have character and boolean char. Now what is the size of this character? 2 bytes. Okay, so let me tell you, the characters are also internally stored using ASCII value. Okay, the characters are internally stored using ASCII value. So you can also consider this as an integral data type as well. Okay, now why the size of character is 2 bytes? So if the size of character is 2 bytes, what would be the range here? Okay, typing mistake. Okay, now let's consider the size of character is just 1 byte. Okay, let's consider the size of character is one byte. So if I say 1 byte, how many what would be the range here? The range would be 128 to 127. Okay, and that means you can hardly store 255 characters. Okay, see, every character is given an ASCII value. Okay, every character is given an ASCII value, and if you use one ASCII value for a particular character, for example, A has character ASCII value of 65, small a has a ASCII value of 97. Okay, has a ASCII value of 97. So similarly, if if I assume the character range is just 1 byte, then you will have minus 128 to 127. That means you can hardly assign ASCII value to only 255 characters. Okay, but the size of character here is 2 bytes, which means if we add these two, what will be the value? 6000 65,565, something like that, or 35, something like this. Okay, that means you can now assign, you can now have these many characters. Okay, and in Java, everything is stored in Unicode format, not ASCII format. So what we'll do, we'll just Google it out here. Unicode table in Java. Yeah, we can do that. If needed, that can be done. Okay, now see, till now, okay, so what they did not, the Unicode format, they did not take the negative value, but what they did, they started using unsigned. Okay, they started using unsigned. Now you see here 0 to 127 for basic things. Zero, 1, 2, 3, 4, A, B, C, D, right? You see on this side, these are the characters and these are the ASCII of that, or you can see Unicode of that. Okay, similarly, you see there is some language like Bengali. These are the Bengali characters and their Unicodes. 0 to 127, 127 to 255, 383, 84 to 670, 17. Okay, this is continuous. This is 3000, 8000. Okay, so if you see, they have given various they have reserved various Unicode ranges to support one or other international languages. Okay, so that's the reason the size is huge, so that it can hold almost all the languages of the world. We could have done that, but see, these Unicodes are will not be defined by us. This Unicode, the ASCII characters, the ASCII values, they are all defined by some standard companies, right? So what they have done, they used unsigned. Okay, so in case of the characters, they have used unsigned, so that means it will go something around 655 65 or 65535. You add these two, okay, the result of this would be the range. Let me check and give you properly. Control R, calculator. 3276, sorry, 2768 into 2, 65535. Got my point? So I say 0 2. And finally we have Boolean. So this Boolean data type can hold either true or false. And these true and false are not constants, but they are what? They are just the literals. Okay, and literal means something which can be assigned directly. Let's say int I equal to 10. Here int is a keyword, I is a variable name, right, or identifier, and this 10 is a literal because I am assigning it directly. Similarly, Boolean b equal to true, you are assigning it directly. You can say false, you can say null. So whatever you can assign directly is called as the literals. Even string name is equal to hello, this is also literals. This is also a literal. Got a point? Okay, and Java also supports hexadecimal, octal numbers. Okay, which means you can also write something like this: int I equal to 010. Yes, if you are assigning something directly, okay, then you can call it as a literals, the direct values. So let's go back to our program, and I'll say int I equal to 10. Sysout system.out.println I2. Let me first compile it. Compile. Okay, the last value is 8. Okay, the last value is not 10. If I remove this 0, sorry, I have to compile it, then it is 10. If I add here 0, now it is 8. The reason is, when you say 0, it will assume this as an octal value. Octal value, you understand? Octal, hexadecimal, binaries. So I am talking about that octal. Okay, and how these values are calculated? If I assign int I equal to 0 1 0 1 0, okay, what will be the value of this? Very simple, just go to this place, say paste. Okay, now what you need to do, octal means 8 into 8 to the power 1, okay, into 8 to the power 0 plus, I'll do like this. Okay, so let's do it step by step so that you can follow it easily. Okay, so the first step is, whatever you have, you split it. Next, what you do, here into 8 to the power 0 into 8 to the power 1 into 8 to the power 2 into 8 to the power 3 into 8 to the power 4. Okay, you do it like this. I mean to say, whatever number you have, you start from this area, this side, right hand side, start multiplying these numbers into 8 to the power format. Okay, and all intermediate result should be added. Okay, so this will be 0, right, because you have 0 here. Now this will be 8, this will be 0, and this will be 8 to the power 3. 8 into 8, 64. Okay, 64 into 8. Let me say calculator. 64 into 8 would be 512. Okay, plus 8. Okay, I don't see any other thing here, so the output should be 520. Let's see the output here. You compile. 1 minute, did I save it? 0 1 0 1 0 only, right? Okay. Java C. Okay, so the output is 520. Okay, similarly Java also supports what? This will give you how much? 8, whereas int I2 equal to 0 1 0 1 0 will give you 520. Okay, similarly you can also write int I3 is equal to hexadecimal, right? So in case of hexadecimal, 0x, okay, means hexadecimal. Now you write your hexadecimal number 108. Okay, so you can write something like this. Which output? The hexadecimal output? No, these are integers, right? Okay, if you have decimal, then you will get dot zero. Yeah, so I said I2, okay, I have not written it here. I'll say int I3 is equal to, the same value will take, okay, and now let's say system.out.print of I3. Okay, so the output what we got from here is 266. We'll see how the output came 266. Okay, so 0x, you forget about this. This is to represent that it is a hexadecimal number. Okay, so what you have is 1 0 and a. Now in case of hexadecimal number, generally what you'll have is, you'll have number from 1 to 10, 1 to 9, sorry, 1 2 3 4 5 6 7 8 9. Then for 10 you'll have a, for 12 you'll have b, 13 14 15, and there is no 16. Is there any 16? No. If f is there to represent 16, 16 by 16 would be 0. So yeah, it will be till f, 16 by 16. Okay, so yeah, so it will be till f. Now here a means 10, a means 10, b means 11. So this is 10, this is 11. Okay, so now our requirement is we have to calculate this 10a. What is 10a? 1 0 a. So can I write 10 here in place of a? Yeah, you are correct. It will start from 0. It must start with 0. Okay, 0 to 9, 0 to 9, then E to F. So this will become whole 0 to 16. Okay, now I have to write it again. Okay, let me delete this. Now we have 1, 0 and A. Okay, now what you do, instead of this A, can I write 10 into 16 to the power 0? This is into 16 to the power 1. This is into 16 to the power 2. And you just add all the intermediate result. Right? So anyway, this 0 will be cancelled, and now you have 16 to the power 0 will be 1. Right? 1 into 10, this will be 10. Plus, now this one, 16 into 16, what would be the output? 256. Okay, so the whole output would be how much? 266. Now that's what you are able to see here, 266, the whole output. Fine. Final result even I gave before that. Yes. Okay, so that's all from the data type side. Okay, so we just have 8 data types, and the data types are either divided into integers or non-integers, floating points, and they differ in the difference between the integers and floats are the way they arrange the data, the way they store the data. Okay, so the integral data type follows the format of 2 to the power concept, whereas the floating points follows the concept of 10 to the power. Okay, and that's the reason, that is the reason, even though you have uh, long of 8 bytes, okay, and float of 4 bytes, okay, still the float is capable of storing more and more data. Do you agree with this? Check this out. What is the size of the long? 8. What is the range of this? The range is this one. What is the size of float? 4 byte. What is the range of this? Huge. So can I say, even though the long is of 8 byte and the float is of 4 byte, okay, the maximum value of long can be easily stored in a float? Okay, so please keep this point in your mind, because we will be discussing something related to this in the coming sessions. Okay, just keep one thing in mind: the long variable is of 8 byte, but still it can be stored easily in a float variable, even though the size is lesser. The only reason is the way they store the data is different. The long follows 2 to the power format, binary format, whereas the float follows exponential concept, that is 10 to the power concept. Are we clear? Okay, that's all for today from my side. Do you have any queries? Okay, so I want to show you one more thing. I just want to show you one more thing. Let's talk about the character. Character ch is equal to a. So when you do this, what will happen? Internally, what is the ASCII of this a? Capital A. I believe that is 65. Okay, or the Unicode is also same. The ASCII character as well as the Unicode character of A both are same. Okay, and it has to be. Again, if I say character cs2 is equal to 65, try to understand what I am doing here. I have just what? A integer value. I am trying to assign it to a character. Okay, now I'll just say sysout, not sysout, you should say copy paste ch1 cs2. Okay, see this, both are referring to the same thing. Okay, so what I want to conclude here is this ch1 ch2, whenever you assign any character to it, it will internally store that based on the Unicode or ASCII. Okay, basically it is Unicode. Okay, basically in Unicode, because Java stores the data, Java stores these values based on the Unicode. Okay, and the ASCII code of A and the Unicode of A is same. They follow the same standard. Okay, now what we will do, I'll say ch2 plus plus cs2 plus plus. So what would be the output here? Will I get an error? Because I'm trying to increment a character. I did not get any error. What will be the output now? How can it be C? Like initially is pointing to A. If you increment it by 1, how can it be C? Okay, B. Okay, so here also the same cycle concept follows. Let's do one thing. I'll go to here, and here I should have Hindi also here. I'll say Control H, sorry, Control F. Hindi, no Hindi. Yeah, we don't call it Hindi, we call it Devanagari. This is the script what we generally have, right? My teacher taught me earlier that we write all Devanagaris. So I think this is the Unicode of it. Okay, 2311 2311. Let's go here and let me say 2311. Okay, now this character is actually pointing to E. Okay, this goes to, this is pointing to this one, E. Now you will get this output if the DOS supports that language. This DOS operating system supports that language, otherwise not. No. Okay, so this DOS is not supporting that. That's the reason we are not able to see the character here. Otherwise you would have seen that. Okay, alright, let's do one more thing. Let me just say I++. I would like to increment this double. Okay, so say Java C. This is data type test. Okay, should say data type test 4001. We'll do one thing. Let's see whether that cycle concept is present in float or not, float and double. Okay, so for that, double, right? So I'll just say double dot max value, double dot max value. Okay, so this will point to max value, and I'll say max value plus plus. And let's print the max value. Okay, so if we don't get any compilation error, that means it supports. Okay, let me also execute that, this data type test. Fine, so this says that it supports that cycle. One more plus plus you want me to do? Okay, the only reason is because this is a class actually. Okay, there is a class called double in Java, and this is the a constant value in that, so that's the reason I'm giving D capital. This is a class. Okay, so you want me to do it that way. Okay, so I'll copy this. So you want to see what is the difference, what is the output we get when we try to increment 2 times successfully and printing it again. Okay, we'll do that. Okay, so the output is these two. That's fine, that's fine. Okay, so the output is this two, and if you see the output looks same, the only reason is the value is actually so large that it is not able to give you the difference. Okay, but internally there would be a difference between these two. Because you are not getting that value exactly in that format, what format you are expecting. Okay, the small d double is a data type, whereas this double with capital D is a class in Java. In Java, there is a class called integer class. In Java, there is a class called a float class. In Java, there is a class called double class. Whatever data types we have, 8 data types we have, right? Here we go. We have 8 data types: byte, boolean, short, character, int, float, long, double. In Java, you will also find the classes similar to this. Okay, I will just show you now, but we will discuss this later. I'll say integer. Fine. Now just go down. Okay, so you see there is a class called integer, right? I'll go to number class, and here you see there is a class called byte, there is a class called float, double, integer, long, short. Big integer, I was just talking about big decimal, right? So in Java, whatever data types you have, you'll also see an equivalent class for the same. What is that? We call it wrapper classes, which we will take up later. Okay, yeah. Now if you want to find out any data types maximum value or minimum value, you can go to that respected class. For example, integer. In the integer class, you have constants, maximum value, minimum value. Okay, similarly these two constants you will find in every classes. Okay, so that's all for today.